Hello everyone and welcome back to Noob Engineering. Today's lecture number 4 that will be on expansion walls and its types. So we are going to learn about the expansion walls given in a syllabus. So without wasting time, we will start our today's lecture number 4. Let's proceed. So first of all, what is an expansion wall? An expansion wall is a device that controls the flow of refrigerant into the evaporator coil of a refrigeration or air conditioner system. It works by throttling the refrigerant, which reduces its pressure and temperature. This causes the refrigerant to evaporate, absorbing heat from the substance to be cooled. Okay, what is the working of an expansion wall? So basically, this is the expansion wall, example of an expansion wall that we are going to study in our syllabus at right side. This is an thermostatic expansion wall. Okay, but what is the purpose of an expansion wall? What does it does? Okay, it simply reduces the pressure. Okay, it reduces the pressure as well as temperature of the liquid refrigerant while it enters the evaporator. Okay, इवेपोरेटर में जाने से पहले ये उसका प्रेशर और टेम्परेचर दोनों डिक्रीज कर देता है. ओके, बट वेयर इट इज प्लेस्ड इन बिटवीन, दिस इज द वर्किंग ऑफ एन एक्सपेंशन वॉल. ओके, दिस इज एक्सपेंशन. ओके, कहाँ से आता है? ये आता है कंडेंसर से. ओके, कंडेंसर और इवेपोरेटर के बीच में लगाया जाता है expansion wall. Okay, now you got the working of an expansion wall and what does it does and how does it works. Okay, let's see the types of an expansion wall. So our first type is capillary expansion tube. Okay, and this is the first one. This is the second one, automatic expansion, and the third one is thermostatic expansion wall. Okay, so first we are going to learn about the capillary tubes expansion wall. What are capillary tubes? You have been seeing a capillary tube in your own college labs. Okay, this is also type of an evaporator. Expansion wall. A very thin long tube that is used to control the flow of refrigerant in a refrigeration or conditioning system. It works by restricting the flow of refrigeration, which reduces its pressure and temperature. Okay, which reduces its pressure and temperature. This is the main working of an expansion wall, and it causes it to evaporate. Okay, its components are as follows. Okay, what components you can see here? This is one strainer that is not means this is the capillary tube, but you can say it is a part of it. The liquid refrigerant entering the capillary tube should it is strained, means it is filtered. Okay, strainer is nothing but a filter. Okay, filter. Then this is the capillary tube that basically is known as expansion wall. Okay, and it's further sent to evaporator and from evaporator to compressor, and the cycle repeats. So working of an capillary tube expansion wall, as explained in the below previous slide, the working of an capillary tube is as follows. Liquid refrigerant enters the capillary tube from the condenser. Okay, the capillary tube is very narrow, so the refrigerant has to flow through it slowly. Okay, as the refrigerant flows through the capillary tube, its pressure and temperature drops. Now you understand why the pressure and temperature drops. This causes the refrigerant to start to evaporate. Okay, as the refrigerant evaporates, it absorbs heat from the surrounding air. Okay, the refrigerant vapor then flows out to the capillary tube and into the evaporator. And in the evaporator, the refrigerant vapor continues to absorb heat from the substance to be cooled until it's completely evaporated. And the further on is the evaporator part, so we are not we have seen in the video number 3, it means lecture number 3. You can check it out. It's in my playlist HVAC. So let's move on to the advantages and disadvantages of an capillary tube. Okay, the first advantage of a capillary tube is it's simple and inexpensive, reliable and low maintenance, no moving parts, excellent for hermetically sealed systems and wide range of applications. So what are the disadvantages? Fixed refrigeration charge. Okay, the refrigeration charge should not be changed. Okay, a limited turn down ratio, ability to adjust the refrigerant flow rate. Okay, वो नहीं होता. और sensitive to change in temperature and load. Okay, and the last one is not suitable for the applications, all applications, sorry. So let's move on to the next one, that is automatic expansion valve. So basically this is the main question that is being asked in all the previous exams. What is an automatic expansion valve? And the next one which I'm going to teach you, that is a thermostatic expansion valve. These two are the main expansion valves that could be asked in exams, so please pay attention. Okay, what is an automatic expansion valve? An automatic expansion valve is a type of an expansion valve that uses a sensing element to control the flow of refrigerant into the evaporator coil. Okay, the sensing element is typically a temperature sensor or pressure sensor. Its components are as given below. Okay, so first one is an adjusting screw. As you can see here, this is an adjusting screw. Second one is a spring. This is a spring given here. Third one is a diaphragm. They can call this a diaphragm. There's a moving plate. Okay, or you can say diaphragm is also okay. It is a moving plate, by the way. Okay, an arm. This is an arm which is attached to the wall. Okay, it operates the wall. The arm operates the wall, and the strainer. Okay, then you know what is the strainer? Strainer is basically a filter. Filter. Okay. Now let's move on to the big picture. So now here we will discuss the working of an automatic expansion valve. Okay, as per you can see here the refrigerant in. Yes, this is the refrigerant in. From where does it comes? It comes from the condenser. Okay, the writing is not too good. Okay, no problem. The condenser. Okay, this is the strainer. Okay, you have to know the working of the strainer now. It is a filter. It filters the liquid refrigerant and sends here in. Okay, what is the refrigerant out here? Okay, this is the refrigerant out. It means where it does it goes refrigerant goes to the evaporator. Okay, evaporator. Now tell me how much evaporators we have seen in our previous videos. Okay, there are 3 or 4. Okay, no problem. But in that evaporators we have seen a sensing element or an what we can say a control valve available in all the evaporators to control the liquid refrigerant flow in the evaporator tubes. Okay, now that work is controlled by these types of expansion valves. Now as the adjusting screw, see here, this is an adjusting screw and it is attached to a spring. Okay, and the spring is attached with the diaphragm. Now this position is closed position. Okay, this position is closed position, but as it moves down, okay, this moves down, the spring moves down here, this moves down, it comes here. Okay, as it comes down here, but when does it comes down here? These evaporator, when the evaporator tubes needs more amount of liquid refrigerant, it goes down. Okay, this goes down and the liquid refrigerant comes in, and when the liquid refrigerant comes in is moves out. Okay, this much is the functioning of an automatic expansion valve. As the need of an evaporate the liquid refrigerant in evaporator tubes increases, the spring moves down the wall with the help of the diaphragm and the spring, and let enters the liquid refrigerant in and out. Okay, this is the simple working of an automatic expansion valve. Let's see the working down. So what's the working of an automatic expansion valve? The AEV, we can call is an automatic expansion valve, is connected to the suction line of a compressor and evaporator coil. Okay, the AEV contains a sensing element such as temperature sensor or a pressure sensor. Okay, the sensing element monitors the evaporator pressure or temperature. By monitoring the evaporator pressure or temperature, means where does it monitors? It monitors in the outlet of an evaporator. Okay, as the evaporator temperature, outlet evaporator temperature increases. Okay, so that is a saturated temperature. Okay, then the expansion valve opens. Okay, this one says that there is a need of a liquid refrigerant. As the increase of an outlet temperature is increasing, evaporator outlet temperature is increasing. That's why the expansion valve is open. Okay, now you understand, for more cooling purpose. Now let's see the advantages and disadvantages of AEVs. The first advantage is its more precise control of the refrigerant flow rate. Okay, as per it uses temperature sensors. Okay, better evaporator efficiency, ability to handle a wider range of operating conditions, less sensitivity to change in temperature and load, ability to maintain a constant evaporator pressure or temperatures. Okay. Now, what are the disadvantages? More complex and expensive than capillary tubes, as it is an automatic, so it is an expensive and complex also, and requires electricity to operate, more susceptible to failure, and require regular maintenance. Okay, as per it works automatically, we cannot trust it, so it requires a regular maintenance, and a susceptible failure could also occur. So let's move on to the last one, that is thermostatic expansion valve. So this one is the most occurred question in the paper. Okay, thermostatic expansion valve. Now let's see what it is. A thermostatic expansion valve, also known as TXV or expansion valve, is a type of an expansion valve that uses a temperature sensing element to control the flow of refrigerant into evaporator coil of a refrigeration or air conditioning system. The temperature sensing element is typically a bulb that is filled with liquid refrigerant. The bulb is attached to the suction line near the outlet of the evaporator coil. Okay, these all the sensing element what temperature sensing elements are always attached to the suction line near the outlet of the evaporator coil. But where the suction line? It is the suction line of an compressor, and that is the outlet of a evaporator. Okay, are you understanding now the cycle? Okay, but you can see the mentioned here where when 1 minute. Yes. Typically a bulb that is filled with the liquid refrigerant. Okay, you can see my last, if you have seen has been seeing my last video, you can connect here. Okay, bulb that is filled with the liquid refrigerant, what we call it as, we call it as an filler bulb. Okay, now you may understand what is a thermostatic expansion valve. There is no any chances that who have seen my previous video would not understand what is a thermostatic expansion valve. This thermostatic expansion valve is directly related to a filler bulb of an evaporator that is flooded. I think it was a dry expansion type evaporator. In that we have seen the filler bulb. It is completely relatable to that. Okay, and the remaining working part is as same. Okay, as the automatic expansion valve. There's no part to what we can say explain it, but that if you have seen that, but let me explain. The components are as follows: arm, diaphragm, strainer, adjusting screw, and filler bulb. Okay, you know all the working of this. Now let's, but here see, it's given here filler bulb. That's what I was talking about. Yeah, let's move on to big picture. So this is in thermostatic expansion valve. As you can see, the main character here, that is a filler bulb. Here, this is a filler bulb, the main karta dharta of an thermostatic expansion valve. So now this is similar. Okay, this is similar. See, this is a filler bulb, and it is attached to the exit of the evaporator. Okay, evaporator tube. In this, you can study both. That is thermostatic expansion valve, and next is dry expansion valve. Dry expansion evaporator. This both comes in here only, means you can understand. These both are correlated. Now, as the wait 1 minute. Let me tell you this. This is the refrigerant, and this is upside down picture now. And this is the refrigerant here. Okay, this is all the refrigerant. Now, let me tell you, as the refrigerant comes here, means now the refrigerant will flow as this will move down. This will move down. The refrigerant will get filled here. Okay, the refrigerant will fill here. The refrigerant is filling here. It moves down here from here. Okay, but as the refrigerant moves down here, it will sense the temperature here. Okay, the filler bulb will sense the temperature. As the temperature increases, means the suction line, it will go from here to compressor. Okay, compressor. As the temperature increases here, the filler bulb will sense it, and the work start of an expansion valve. It expand the what we can say, the spring expanded. The spring expands, and the what we can say, the liquid refrigerant comes in, and I guess it goes in. Why? Because there is a need of liquid refrigerant in an evaporator tubes for the cooling purpose. Okay, as simple as the dry expansion evaporator. Only the main karta data is here, the filler bulb. Okay, this was the working of a thermostatic expansion valve. Okay, liquid refrigerant enters the thermostatic expansion valve for the condenser. The TEV contains a temperature sensing element, which is typically a bulb filled with liquid refrigerant, that is also called as filler bulb. The temperature sensing element is attached to the suction line near the outlet of the evaporator coil. The temperature sensing element controls the flow of refrigerant through the walls. Okay, if the temperature of a refrigerant vapor is in the suction line increases, see, listen this, it's important. If the temperature of a refrigerant vapor in suction line increases, as I told, the pressure in the temperature sensing element also increases. Means the pressure increases in the filler bulb, then this causes the TV to open wider, allowing more refrigerant flow in the evaporator coil. This is the simple working of an expansion valve. If the temperature of the refrigerant in the suction line decreases, the pressure in the temperature sensing element also decreases. This causes the TEV to close tighter, restricting the flow of refrigerant in the evaporator coil. Okay, this is simple performing. The TEV will continue the adjusting the flow of refrigerant into evaporator coil until the desired evaporator pressure or temperature is reached. Okay, now let's move on to the advantages and disadvantages. So what are the big advantages of it? It is more precise control of refrigerant flow, better evaporator efficiency, ability to handle a wide range of operator conditions, and less sensitive to change in temperature and loads. Okay, this is the best expansion valve used in today's industries. Disadvantages of thermostatic expansion valves: more complex and expensive than capillary tubes, requires electricity to operate, more susceptible to failure, and requires regular maintenance. Okay, now here we can conclude our first chapter. Okay, and the second chapter to and the second chapter starts. Okay, sorry, and the second chapter starts from here. The first chapter is over. Now the notes will be provided in the Telegram channel that I have created. The link is in the description. You can join there and study from my notes for the NSEM exams. As the exam forms are started, also you have, I think you have filled it. If you've not filled it, I will give you the link of the exam form. You can fill it from, uh, you can take it from my description. And okay, keep studying, and let's meet in the next video. It is lecture number 5 that will be conducted on safety control devices. Okay, so bye, take care.